So before we start with the actual content from today's lecture, I want to recover some of the notation that got lost in the previous lecture. So if you have a function of one variable, so with domain a subset of R, with one output, then before all this fancy root-in stuff, we actually had a notion of f prime x, right? And that was this. Now, this has been replaced by a linear map version of f prime x that ends up being this kind of thing. And what number this limit comes out to be, so here x is fixed. So whatever number this limit comes out to be is going to be the scalar by which this linear map scales things. However, I will often want to refer to this scalar still, and now I've done away with the notation for referring to it. So in root-in, when you're doing the reading, I think he says things like, sometimes we can treat this as a number and sometimes we'll treat it as a linear map. And we're using sort of the identification of this vector space with this one. But it would be good to be a little bit more careful and less sloppy than just to use the same symbol for two quite different types of things. So here's what I propose. For this number, let's use this notation. How about we do it like this. Okay, so one approach is to just say this, but I think this lacks the exact level of precision we might need sometimes because, it's not clear whether what we're getting is a function of x or a number. This looks like it should really be a function of x. So actually what I'm going to do instead is maybe something like this. So if you have a function of one variable and I write dd that variable, evaluated at that variable equals some other thing, then that's this number, which we used to refer to as f prime x. Now instead, f prime x is a certain linear map, and if you want to know the relationship between the two, then it's this. It's that f prime x is a linear map that when applied to a vector, which is just a number here, outputs this scalar times the vector. Okay, so from now and for the rest of the course, we have two notations for derivatives that work in slightly different ways. The prime notation gives you a linear map and can be used for a function of any number of variables with any number of outputs. So I can put Rn here and Rm here, and this notation would work perfectly well. On the other hand, there's a second notation, Ddt, sometimes with an evaluation symbol, which serves to take this limit that we used for our limit definition of derivative originally